In this lesson, we will look at section 5.2, Properties of Functions. In this lesson, you will learn what is a function, how to determine if a set of ordered pairs represents a function, explain why some relations are not functions, but all functions are relations. First, let's look at some new terminology. First, the domain. The domain is a set of first elements of a relation. So if we're looking at a table of values, the domain would be the column on the left. In an arrow diagram, it would be the first oval on the left. And a graph, we would have the horizontal axis, the x values. That's only some examples for the domain. Range is a set of related second items of a relation. So in those same types of relations, a table of values, the range would be the second column. An arrow diagram would be the oval on the right, and the graph would be the vertical axis, the y values. So you have to keep in mind that the domain is the independent variables, while the range is the dependent variables. A function is a special type of relation where each element in the domain is associated with exactly one element in the range. And during this lesson, we're going to look further into a function. Let's look at how to identify functions. A function is a relation in which each element in the domain is matched with only one element in the range. So if we look at the first example on the left there, this arrow diagram represents a function since each student is matched with one grade on the test. So each student, Linda, Sheldon, Dean, and Andrew, they're only matched with one element in the range. So therefore, that arrow diagram does represent a function. In the second example, it's switched around. The grades are now the domain and the students are the range. But that doesn't matter. We just have to look at the domain and see if it's matched with only one element of the range. And as you can see, the 70% in the domain is matched with two people in the range. It is matched with Sheldon and Dean. So this arrow diagram does not represent a function. Next, there are some strategies to determine if a relation is a function. With an arrow diagram, each element in the domain must match to only one element in the range, which we just saw with those students and their test marks. Ordered pairs, we have to look for repeated values of the independent variable. So each independent variable cannot have a repeated dependent variable. For a graph, we have to use the vertical line test. When a vertical line intersects the graph at more than one point, the relation is not a function. So as you can see from the first point there, all functions are relations. We can use functions and relate them as an arrow diagram, an ordered pair, a graph, table of values. But all those relations are not a function. If those relations do not meet the characteristics that a function describes, then it is not a function. So the vertical line test is a test that can be used to determine if a relation is a function. So there are two particular rules you have to keep in mind for this vertical line test. If the vertical line intersects the graph at more than one point, it is not a function. If the vertical line intersects the graph at only one point, it is a function. So if you look at the examples on the right-hand side, we have four different graphs. Looking at the first graph, the vertical line intersects the graph at exactly one point. Therefore, that relation in that graph is a function. If we look at the other three graphs, graph 2, 3, and 4, that vertical line intersects those graphs in two places. Since that line intersects at more than one point, that relation or those relations are not functions. Now, in summary, we can look at this table here that shows an example of a function and a non-example of a function. The first example of a function is a table of values. All the x values in the domain have a separate range value, similar to the ordered pair there, the set of ordered pairs, and the arrow diagram. So everything has a separate answer for the domain and the range. So every domain element is matched with a separate element for the range there. But this is not the case for the non-example there. We have the table of values where we can see that the number of faces of 6 is matched with 2 objects in the range. It is matched with a cube and a rectangular prism. And we're taking that same table of values and we're writing it as a set of ordered pairs. And again, the set of ordered pairs, we have 6 for a cube and 6 for a rectangular prism. The domain has 2 answers for range, which cannot happen for it to be a function. And lastly, the arrow diagram is probably the best way to look at it because it's a visual representation. The 6 is being matched to 2 elements of the range, and this cannot happen. So what you have to take away from this lesson, in order for a relation to be a function, every element of the domain must be matched with exactly 1 element in the range. If you're looking at the graph, you can use the vertical line test, where that vertical line must hit at one place on the graph for it to be a function. If it goes through the graph in more than one place or more than one point, the graph will not be a function.